Norm, can you describe your design process when you first
Well, I
acquire a
mentioned
new
the
project?
graphic program. That's one of the first things. But before that, I like to walk over the site. There are always something in the site that's going to have an impact on the design. I want to see what its context is. If it's a hilly site, then we need a survey that's very accurate, those kind of things. But I want to have that site information right from the beginning. So that program is a big start, and then it begins with determining whether the program that you have has other interesting opportunities for design. So we need to know what are those elements. If they've been described accurately, that's fine. If not, we need to identify what they are with meetings with the client and continue on. But I think it's easiest for me to kind of walk through some of these projects, and you'll notice they are not one specific type of functions. As I mentioned, I was never interested in being a specialist in one type of project. I think the interest for me was the design challenge of the varying size projects and their functions, and what are some of the major things that influence that particular design. So why don't we start and walk through some of these projects, and they'll remind me of what was important to me in terms of the design function that we ended up with. I should say again and repeat that it's always been a team function that I work with. We identify the team that's a complete team of the architects that will be assisting in the project. It's a complete team of engineers that are involved in the project, and of course that'll be very depending on the size of the project and the complexity of the project. And it's not unusual for us to call independent experts. We've had a project where we hire laboratory planning consultants, where the techniques and the systems are beyond our understanding, and they work very easily and comfortably, and we find that to be most helpful on defining, say, the highly technical laboratories, which are among the type of buildings that we do. Or we've done projects where the inner workings of a building are done by that company. We did a fair amount of work for Union Carbide that were producing battery plants. Well, we don't know very much about battery plants, but they know a lot, and so they tell us what size space they need to do their function, and then they provide that within their own capabilities, things like that. So I enjoy the varied kinds of people that you associate with during these team building processes, and I'll elaborate on those in some particular instances as we go along.
You had mentioned to me some time ago that you used a cube perspective method. Can you talk a bit about what that is?
Well, drawing is one of the things that I've always had an interest in, and a fair amount of capability in it. As a matter of fact, one of my first temporary jobs when I still was a student to do renderings for a large architectural firm in Minneapolis while I was at the Minnesota School of Architecture. But there's a very elaborate technical system we were taught, but it was just something I thought could be improved, and so I called it a, what did I say, a graphic cube. I would design, say, or start to lay out, say, working from an elevation or a section of a building, so that I'm on one flat plane, and I would project from that, let's say, a 10 by 10 by 10 cube, and I could take that in 3 dimensions, horizontally in plane and vertically. And just by eye, you have to start at a very small one so that you can't go indefinitely or it gets out of proportion.
Okay.
But that allows me to locate a point on that, anywhere on those 3 dimensions. And I just have found that works for me. And that's what I've been using for the last 50 years or so.
Good.
I taught it at our office one time too, where I tried to teach it to a group of guys. I don't know whether they followed up on it, but
Yeah.
I can show you some examples here among some of the drawings I
Okay.
have. So,
Perhaps we should, you know,
why don't we start then?
okay.
Right behind you, on the bottom part, is Shepherd Knapp School. That's a K-12 school in Massachusetts, and it's located actually on a farm site. They were using some elements within the big house on the farm for their classes, and we were able to get a contract to design a new facility for them. It's a very beautiful rolling land site, not a huge school, but here, because it's located in and on a farm site and the buildings are of wood, it seemed most appropriate that here's one of the factors that influenced the design to be of wood.
Mm-hmm.
Not too complicated. And the scale is more in a farm building, residential barn scale, I thought. But we had advantages there. You see in some of the things, there's a rolling site and there's a opportunity for architectural feature at the entrance with a retaining wall of natural stone at the front door entrance. That's one of the factors that affected the site, affected that particular design solution. And the rest is just the roof shapes are, again, similar to buildings that you might find on a farm. So it makes for a very pleasant environment. We got a few arches in the main corridor. Turned out very successfully, and they were very happy with it, and it was a fun project to design.
This was done with Dalton Newport, correct?
Yeah, these are all Dalton
Mm-hmm.
Newport. Or Dalton, this may have been Dalton, because that dates from the early 60s, 1960s.
And from
there's
there,
an example of one of my drawings down below, but you can't see the use of the, what did I call it, the cube,
mm-hmm.
the vanishing cube. Now we're still in the 60s. This building up at the top is the headquarters for B.F. Goodrich Rubber Company in Akron, Ohio. And that was designed in the late 1960s. In the office, our office at the time was in the old arcade building. And here's an example where the materials had a big impact on the project. I have certain materials that I like to use if it's technically possible. This is made of granite, and you'll see some photographs where there's a large bridge connecting it. The utilities from the plant, the existing plant, which are on the street opposite, and I'm sorry there aren't any direct photos of it, but the plant, the B.F. Goodrich Rubber Company plant that's there, is very, very large. It's where they were producing all their tire manufacturing. And I would guess that the earliest buildings across the street there are in the early 1900s. The bridge then provides access from that part of the building as well as provide the utilities that will service the new headquarters building. And the building itself is located in a piece of land that the city of Aurora called Opportunity Park, where they planned future major structures to be built on that site, but of a major importance. Parking then was provided in that as a separate building. Large building, I think it was in the neighborhood of over 300,000 square feet of office space and related functions. As I say, the granite, I picked a granite that matches the brick that was in the industrial plant. It comes from South Dakota. It's carnelian granite. It's in a reddish brown color. And then glass where the main office floors are, all functionally planned so they could be repositioned as needs develop in the future. The complex is on this large property, that Opportunity Park, and we used a landscape consultant in this project because we felt of the importance of the major site area to be developed. And I think that was one of the kinds of things. Although our office did have landscape architects, we thought that a notch of more character for the landscaping should be involved.
It's still a very iconic building in Akron. It's held up very well.
I don't know what it's used for currently, do you?
It's a headquarters for Bojo.
Oh, I should go by and see it.
So,
Now, underneath it now is one of my favorite buildings. This is the Ohio Bell data center for their whole complex of computer operations. This was also in the late 60s. So that was in the early days of computers. We didn't know a whole lot about computers, and this was one of the instances where their staff developed the program.
mm-hmm.
We didn't have any idea what that was, and so that was the only thing that way we would have been able to operate is someone had to tell us where they were. And as it turned out, we had a young architect on our staff. He was from Austria. Well, I'll remember where. Austria. He was from Austria, and he took an interest in computers, and he actually developed a program that once we had the facilities identified by the Ohio Bell staff with the square footage, he developed a program that could assign the relationships so that function A had to be right next to function D, mm-hmm. and so on, to the exact square footage. Then in consultation with the structural engineers, they developed a 30-foot by 30-foot program in concrete construction would be a suitable facility. And he developed a program that took the functions that had been identified by the client and the square footage and create an actual plan showing that those functions together. It's down on the floor. Did somebody get that? So, that right on the floor.
This is good, Rich.
Or no, sorry, it's right
Yeah.
on the wall, the last one.
You want me to pull this off?
You can't, yeah. Or I'll leave it there if you can photograph it.
Yeah.
Well, that shows the plan in relationship to each other. They were color-coded so that we knew which one was which. And then it became a relatively simple plan for me as an architectural designer to locate the circulation, the corridors, mm-hmm. locate where the toilets are, where the stairs are, where the elevators are. those kinds of functions that are necessary. And that really developed the plan of the building. And then it was our job, how do we make something that's workable and functional and beautiful? And I make drawings, you'll see maybe one illustration. Somebody once said, architecture's easy until you get to the corners, and that's one of the reasons I make these kind of little study drawings to see how the various components can fit together. I probably do more than that. The one drawing, I probably might have had 30 or 40 or 50 of those along the way, but I just don't have them here anymore. They're probably in some file. And we actually used to use those kind of drawings in the schematic phase to explain to the cost estimators what's going on in the building. And we used to put it in our plan drawings, schematic, to show to the client. It's a great asset to make them understand what we're doing in our design. And so the whole building then really picked up from these associated drawings that show the relationships. And we didn't have the technology to do it for the whole floor, so we had to do that just separately for each building floor as it developed. It's a concrete structure. Concrete is one of my favorite materials because I kind of think of it as an architecture. If this were a sculptor and he had a big chunk of concrete or a big chunk of rock and he wants to make something beautiful, that's in essence, that's the direction I would be thinking architecturally with one basic material. In this instance, it's concrete that's used two ways. The structure is a concrete, and the floor slab is I think it was a 5x5 cubic plan. You see a little bit of it in that one photograph toward the bottom on the left, which were throughout the building. And then we used precast concrete for the windows. You can see that in the drawing a little bit, and those are the windows that are angled so that there's some sun blockage. There's a very large computer floor that's underground, which was designed specifically by the client to be underground for security purposes.
One of the things that I really admire about that particular project is how you carried the inside to the outside and the landscape, the integration of the landscape and so forth. Mm-hmm. And I always assumed that it was because the people were looking at computers all day and it would be a great relief to get outside.
Yeah.
And so I admire your approach to this.
There's one area that became a flat roof that you see some photographs of that, and because underneath that is a large computer floor. And so we put plantings on it, and we put a large rock on the surface of the roof so you don't get a black roof.
Yeah.
And I haven't been by there to see if they've maintained those planters, but that was a necessary part of the design. Okay, well, this next project is the upper portion of the window here. This is Florida International University Multi-Function Building number 2. It's a developing campus. This was in the 1970s, and the site was a previous airfield. If any of you have been in the Miami area, this is off the Tamiami Trail, and it was Tamiami Airport that was abandoned or anyway made available for this new campus. And as you might guess, an airfield is pretty flat. But in Florida, you have the ability to kind of stick a piece of wood in the in the soil and it'll become a tree. So these trees came from that technique. They're very close to the water line, so they dig a little bit to elevate the area for flood protection, and that creates a whole series of these little lakes and ponds. So the site can become very beautiful from what had been just a regular flat site. So those are the kind of factors that come in and influence the design. Also, of course, the climate here. There are many areas within this that are within the complete context of the buildings, but are open to air. So you mark through and the air is vented out up above and making for a very comfortable and protective space out of the rain when that happens, but still in open space. The function, it says multi-function building, that just meant there's about 3 or 4 or 5 different functions that could be built initially and then maybe converted to some other function as the campus grows. Plus, it had one major component, which was the mechanical plant for serving the whole campus. And those elements had to be incorporated into it. And I chose to try and use it as within the same materials and same kind of forms. And so it's hard to identify if you don't know which is the mechanical and which is the educational. But they're both there together working comfortably side by side. Concrete is another factor. Almost all of the buildings in the campus previous, this was the 4th building to be developed on the campus. And all the other 3 that were already occupied were concrete. So I saw no reason to change that, and concrete was, as you might have been aware, here we now are carrying on the concrete elements of structure. The difference in the team planning here was I was still located in the Cleveland office, and so this was a developing office in the Florida area. It was actually the first architectural project I had. We had sent down to Florida the some of the engineers that were currently located in the Akron office of Dalton.
Okay.
So I had to do much of the planning down there. I'd go down there for a period and work and then come back to Cleveland. But we used local engineers who were familiar with the Florida area, and that worked out very good. One of my favorite buildings, maybe one reason, is because it's concrete and because of the elements of the site and all. And they ended up very, very happy with the project. The next project now was probably, from the point of view of importance in the architectural world, this is a very critical project to be able to work on. This is the Uniformed University of the Health Sciences. It's on the National Naval Medical Center site in Bethesda, Maryland. And it's a medical school for the military. They get officers or people coming from the various branches of the armed services for medical training, and has become an important cog in the development of care for the types of wounds that are being occurred by the current wars that have been going on for so many years. It was an important project to get. It had it's a small photograph here. That's the total area for the National Naval Medical Center. I think there's over 200 acres there. And this building complex is, can I stand up without destroying something?
I think so.
This is the hospital, and that was another project. I'll explain that in a minute. Here's the site for the NNM, National Naval Medical Center, Uniformed Services Health Center. It was in a jungle of trees, and that became an important design element. They wanted to preserve the nature of that the students coming here have a very concentrated course, and to be able to be out in the open air and enjoy nature would be an advantageous condition for their study. So that was a design purpose. It also had started getting students, but this project dates from, it actually began in 1974. I think I joined the office there in late 1974, but then worked on site through 1975, and then back in our home office. The last building was developed in 1981, but all the designing had to be done before that, in that 1975 phase. So we were obligated by contract to develop an office in the area close to the site. I should at this point say this was a large joint venture. We joined with a firm from St. Paul, the Ellerby Company, and their project was to be the major addition to the hospital. So there's two main projects ongoing at the same time, and each office had to develop their project with a team close to the site.
Mm-hmm.
Then there were some other areas like that affected some site master planning, and there's a booklet down here that explains all of that, and other sort of other projects that come along other than just the two. And they both would be built at approximately the same time. So the hospital is the one that's by Ellerby, and the medical school is by Dalton, and we're occupying space in a rented building in just north of downtown Bethesda. And we'd be there for the full week.
Mm-hmm.
Schedule was an important criteria. They had the master plan that you see there had been developed previously, and that's a function that has to go through certain processes in the Washington, D.C. area. All plans of this nature have to be presented to and approved by National Capital Planning Committee, and then also by the Washington Fine Arts Committee. So those are steps that have to go along the way and get approved before proceeding. And these went along very well without any problem. The planning would be such that it would be built in phases. And these bottom photographs show the models that we made. On the very left is what was identified as increments 1 and 2, or A, B, how was it? Yeah, the first and the second. On increment 1, the design of that had to be started for design before the entire complex was really planned. And it would set the stage in architecture, detailing, planning to be the same characteristics as what was done in increment 1.
Mm-hmm.
So that that was our initial design task. The second one is increment 1, 2, and 3. And increment 3 was this 2 floors of laboratory space on top of the first 2 floors. That would have been in increment 1 and 2. And then there was a 4th phase, which expanded for other functions within the entire plan, such as the nursing school, I think I can't remember all of them, but it was, you see, it's really the terraced structures that come along. But what was built initially, or what we had designed for, was increments 1, 2, and 3. And we were very far in those, in our planning, when word came down, we have to delete, for financial reasons, increment 3. So that was a big step. What you can see the difference between 1 and 2 of the photographs. So it still survived architecturally, but would have been much more powerful if with that number 3. And number 3 has not been built to date. The materials, I chose the brick to coordinate to the, you see the fair amount of existing trees there, and a little pond. In, where the second picture there is the main entrance that you see. Is you could drive up along there and drop people off, or go underneath it, parking. There's 1,500 cars underground underneath this complex. And the location was placed on what had been a pond in the middle of the forest. And we did that purposely so that it would minimize the amount of trees that would have to be removed to allow for the building. And so the building is really surrounded by trees. We maintained a portion of the pond that come up to it. You can see that in maybe 1 or 2 of these buildings. And in the fall, with all these trees here, the ground is covered with these reddish tan leaves, and so I chose a brick to coordinate in color with that. And the main structure would be concrete, both structural concrete, sandblasted, and then some areas of windows and things that would be precast, not unlike what was done in the Ohio Bell data center. But the brick played a major portion because of identifying with the surrounding leaves. The concrete was picked for use in many of the interior areas. The library, which you see in one of these photographs, is a 2-story structure, and it opens up onto the terraced areas where some of that area is to be landscaped, so they could go outside and read or do their in a comfortable environment. And also in the main cafeteria space. And there are 2 or 3 individual dining areas for special meetings or together with food purposes and things of that sort. It was an important project for us, and it was important to the government. The groundbreaking was attended by President Gerald Ford and the Navy Band. The Navy Band played. It was a big ceremony. I have a photograph of over here of that's David Packard. He was chairman of the board, and he's congratulating me after the opening of Phase 1. And the statue underneath is the Congressman F. Edward Hebert from Louisiana, who was the proponent for this facility for many years in Congress. As you can imagine, it didn't go easily through the course of the political situation. And he was honored then with a location with the, after the first phase had been built, they had located this statue and asked me, could I find a place for it? The building is built. And so I looked around, and there was one spot I thought could work. It's in that middle picture. So it's in the courtyard. On one of the walls were a stair, so it's a blank wall. And I worked on it, and then you see the results of it. They just carved into the existing wall. There's a stairway behind that, and the sculpture is positioned, and it's all bronze behind them. So it worked out nicely.
You mentioned the complicated approval process on this particular project, but many of the larger corporate complexes that you have designed and governmental projects and so forth have internal architects. How big of a problem has it been to work with the internal architects?
Let's see if I can remember the process. We never had any objection. You'd meet with it's by committee. There's a committee of architects and planners at the National Capital Planning. So that's the only association we had.
Okay.
Now, it's not unlike what I'm familiar with in the Cleveland process, where you have a group of architects and someone comes with a project. So it was not unlike that. It's just more high-powered, so to speak.
Okay.
And so we made our presentations, and everything went along without any adverse problem. You also make comment regularly to a public group. This had to have there was another kind of public related thing having to do with the environment, an environment assessment kind of thing. And that's made to a public group or neighbors and things like that. So I would go there with the people that were representing the military. Our liaison was with the Naval Facilities Engineering Command, and the reason we had to be having a joint office in the vicinity was so that they could come by at regular intervals and be aware of the progress, and then be ready when you had to go make a public presentation to the public for those various kinds of other meetings. So the representation of the U.S. Navy was one of my favorites among clients. I mean, I found that to be just an excellent kind of association. There was a couple of lieutenant commanders doing the basic thing. Of course, there are associations higher and higher up the military scale in terms of up to the admirals. So we even had one meeting with the admiral at the Pentagon for something, some purpose. But I found they were very intelligent. They make decisions properly and expeditiously. And I enjoyed very much the whole working process. In fact, one of them ended up becoming an admiral. And he used to invite the project manager and myself to his change of command ceremonies. So I thought that was that they represented the military, and we did an adequate job of producing on time. It also was an award winner. It won what's called the Blue Seal Award, which is the best, what's it say? The most outstanding design for 1981.
Yeah.
That's a very coveted award.
Mm-hmm.
And then another one underneath for the American Institute of Architects and the Naval Facilities Engineering Command. There's a photograph at the bottom of me at a younger age and some of our team. That's a working model that we had. And I should say at this point, we were very proud of the job we did. We knew we had a tight schedule, but we managed to work within the scale, within the time frame. And it went on over the years very significantly. The honors that they received were just so much thing, but we had at the time a notable architect representing consulting for both firms, both Ellerbe on the hospital and Dalton on the medical school. And we became friends through the course of that, and I brought a letter that he wrote. He had to make a review every time. Every so often he'd come and he wrote a memo then to the rest of the staff that I'd like to have you look at it. This next project, the upper part of the display on the windows, is the Master Builders headquarters. Master Builders deals entirely with concrete additives and concrete products and to the industry. And so the building was to be their office area and a laboratory for experimentation in various admixtures and things that are related to concrete. And then there's two sort of small lecture or meeting hall things. They were typical in having sessions with people in the business, concrete manufacturers or people doing with concrete, and they would have a presentation on concrete in those two facilities, and then maybe have a little cocktail hour or some such thing as that. So it had multi-functions, but all related in some way to concrete and the production of concrete. As you might assume, the building had to be concrete. I had done a fair amount of concrete in the past, and when they were selecting architects and engineers, they selected us for the architecture, and then they selected Dick Gensert's office for the engineering, and I thought that was kind of interesting. And he was a big asset. I enjoyed working with the engineer they sent, and I'll tell you as we go along, one of his just small suggestions that worked out terrific. It's located in Beechwood, Ohio, just off of Chagrin Boulevard, on a site that has it's right next to Chagrin Boulevard, which is a very busy street during the rush hours, and then it's off of an office park development that was part of Beechwood at the time. The plan developed rather quickly, as I remember. We have a large office section, levels. The lower level is partly in a depression, and yet usable, very much so. And then center entrance off of a public area, and then employees have entrance off of the parking lot, which was toward the other side of the building. And so that center part is really those functions where they have the more social things in the meeting and display and things of that nature, where the public or the people that are interested in learning more about concrete come for their seminars and things of that nature. And then the laboratories, which are very much developed for their studies of concrete, where they actually produce concrete and then study it for various capabilities. You see some of the photographs of the public space. That's the center long section, the two-story section, an entrance off each side, and then a couple, at least then in the middle, there's one of the seminar areas, a flat floor. The other one, which I unfortunately don't have a photograph, was a step floor, but it's adjacent to this. So those are kind of the public presentation areas, and then a little bit of a portion of one of the laboratories. I liked this building because of those different functions and how they could all relate, and I'm using my one material theory as if it were a block of stone and I'm carving into it, and it worked out very successfully. The building was built in about the 1980s. At the groundbreaking, we were invited, and there's a block of solid brass. That's what they gave to all of us at the groundbreaking. What?
It's a very handsome, clean building, and it's held up very well. And when you drive by it, I think it's a very handsome project.
Thank you. The concrete had to be concreted, as I said, and master builders selected the aggregate. That's the stone that goes into the poured part of the concrete. And it looks very white. I don't think it was exactly white cement that we used, although I can't remember now. And it's also, much of it is poured in place with a sandblasted finish with a few elements that are precast. And because it's concrete, I took some liberties. You can see a sketch I was looking at up in the middle, that long shaft of concrete which starts in that second floor space and then just keeps going out. A good place for the logo.
Very nice.
Yeah, I was very pleased with this building. The head of Master Builders at the time we were in construction would come out to the site every night after dinner and examine how the process went. So if it didn't work right, they had to do it over again. And it was very successful. Now, at the building now on the bottom photos, that's the Ohio Bell headquarters building. And Ohio Bell has had quite a variety of things during the time this was built. This was in the, what do I say, like 1984, in that neighborhood. And it's no longer owned by Ohio Bell. I think it's by a private real estate company. And I haven't been in it, but I assume it's still as an office, various office functions. It's a 16-story building, and the material is granite. As I mentioned earlier, granite's one of my favorite materials. This granite comes from Texas. It's called Texas Pearl. And it was picked to coordinate with these lower buildings adjacent to it, which are concrete. So that was a purpose-made decision to coordinate. I thought that was the best way to integrate it into the complex, even though it's much larger. It's not the same material, but the coloration continues. And there have been many developments of the open plaza, which was there at the time of 1984. So there's additional construction that's adjacent to it. It used to be kind of an open pond. It's on a corner site, and that affected the volumes of the building. I studied a number of those, and of course there are a variety of functions in it. There's the main office floors, which are the ones that contain the curved area as well as the front elevation. And then there's various elements that are used for training and meetings and things of that nature on the grade floor, and that's expressed in that lower section. And then there's some other functions for the public off of the main entrance floor, but coming in the main entrance where the three doors are with the cap roof on. That roof on top of the doors there, I wanted that form because I thought it configured nicely with the large curve of the office section. And I realized somewhere along the line that the what's the name of this, the speedy little car that the General Motors makes? It's a plastic or fiberglass body.
Oh, the Corvette?
Corvette, yeah, the Corvette. So I said, well, if they can make the fiberglass body for the Corvette, they ought to be able to make a fiberglass cap for the rolling door, and use the same paint finish.
Mm-hmm.
And so they did. It certainly, I think, helps identify where the front doors. The the building has pretty much an open floor plan, and the windows on that south side, the lake is to the north, and so from those curved windows, everybody gets a great view of the lake in that floor. And on the other side, the windows are slightly sloped inward, so that as the sun comes around that side, it gets in shade. And it was the subject of an article in one of the engineering magazines about the engineering developments for this building that were unique to the current practice. And that's one of the examples of the enjoyment I get from working with a creative engineer. I've discovered that that slope on the window, the office I was sitting in my office, I began to notice that the window, I'd put something on the shelf of the window and the sun would come around, so I calculated it. I mean, I just marked it down and then got the results of that, talked with the engineer, and we designed the windows to slope at a certain elevation to reduce the sun glare. There was another important, interesting angle. During the course of the design process, we had a working model, and I would, when we were going to have a meeting with the client, I would go around and get a little piece of paper and crumple it up in my hands, and then cut a piece off of it or a little bit on and stick it on the wall like a piece of sculpture. Worked effectively. but it initiated a full-scale art program for the building. The executive officers told us, that is myself and the two representatives from Ohio Bell, who had been our liaison all during the regular meetings over the course of the design time for the project, were authorized to go out and select paintings for the executive floors. And it was that the top-level executives would be able to get 2 paintings of their selection from what was selected by our little committee, and the next level would get 1 painting for their office. Then in addition, we got, in conjunction with the people from the Cleveland Museum of Art, introduce 2 major pieces of artwork. You see in the bottom central picture off to the left is a large hanging fiber artwork by Sheila Hicks, who is an internationally known fiber artist. And the museum got her into the picture to develop a piece of her work in the main lobby. And Jim and I were just talking, I wonder if it's still there, since the building is not owned by Ohio Bell. They had an internal competition among local artists to design something for the long wall that's just adjacent to the main lobby. You see just the corner of it in that bottom photograph. Mm-hmm. There's like a triangular piece, just curls around the corner. Do you see it?
Yep.
And that goes all the way along the wall to another entrance into the building. And that design was done by David Davis. It was a little internal competition among local and regional artists. So that was really, I'm not sure how often that would happen, but I thought that was a very unique and very intelligent decision by the executives to introduce artwork. Mm-hmm. Oh, and I remember also up in the executive area, I had gone to an exhibit of African art, woven rugs. A lady here in Cleveland used to gather those, and I'd seen them at some exhibit, and I was fascinated by them. And I think for Ohio Bell, purchased 2 or 3 or 4 that they then hung on the walls in the executive office area, where the general office area would be. Mm-hmm. The secretaries might sit. So that was another example of artwork into the complex. The granite comes from Texas. It's called Texas Pearl, and it was picked specifically to coordinate in color to the concrete lower level buildings that are adjacent to it. Since the site ends with that building, I thought the color should be very sympathetic to what's existing, even though it looks like in this photograph like it's exact, but I think because one is concrete, that's the lower level ones, and then the office building for Ohio Bell is concrete. It's not a smooth concrete, it's granite. It's flame finished, which exposes the material in a little different, more, I'd say, not a shiny finish. Here's another example. You know, I forgot to mention one of the things that on the Master Builders project, you see the long wall at the end of the office portion? Mm-hmm. Well, the plans were developing that way. It's a long wall with, then on the end of it were the utilities, the bathrooms and things like that. And I had a meeting with the structural engineer, and he looked at it and he said, you know, he said, we could design that whole thing with a 90-foot beam. I said, well, that'd be pretty good. And so that's what they used. And long span beams and much of the other laboratory spaces. But that main floor then becomes a clear span. The long length of it and
Yep.
the width of it were clear span, and you see where that little window is dividing, then that other little section is where all the utilities are. Nice clean plan, a nice clean structure. The Ohio Bell building has a number of mechanical innovations, and it was on the cover of one of the technical magazines of the day. The structural or the mechanical engineer and I were working together. He had a number of novel solutions that he thought could be applied in this building very effectively. And the windows on that front south elevation are sloped inwardly, and that's the result of a little experiment I had in my office where I was working at the time. And I had a window, and with the windowsill, I was watching or seeing the patterns of the sun as it moved throughout the day. And so I calculated what those angles were, and then we coordinated it to the window, sloped it to a certain angle that would give it the best shade protection, and not to do anything awkward inside. So you see that on that lower photograph on the right. And it became the subject of one of the magazine's articles. Okay.
The next project was being completed when I moved to Ohio, and it's a pretty fascinating project for me because I've had a number of MRIs, but this is the MRI facility at the clinic. And there's no steel in it, is my understanding. Is that
That's
correct?
right. This is from my understanding, and there's a little article at its dedication down there that explains more of it. But as I understand it, it's the first building that was designed specifically for the MRI in its own building, not occupying an existing building space, which is what many of them did. And so the objective was to make it completely free of anything magnetic substance. So you didn't want any ferrous materials in it. That created the idea, the dedication for everything in the building would not have any effect on the large magnet, which is the driver of the MRI. MRI is magnetic resonance imaging. In the first I think the title of that process initially was not magnetic, but I can't remember what it was. There was a more objective term. It'll come to me. And the plan really fell into place very quickly. The round shapes are within the power of the machine. It emits a magnetic field of a certain diameter, and so the building itself was round to accommodate that, and then we put outside that a wall, a brick wall that curved to the exact extreme range of that field, so no one would accidentally walk into it and have all their watches and everything be affected. And inside is all wood, and the brick out is the outside surface, and inside is more just block and wood beams for the doors, and of course a nice wood dome over the machine itself. It's a dome shape that serves for the upper functions of the machine. And the machine room that operates this outside is the window. So as a patient coming in here, it's quite a dynamic difference in the environment. Much more friendly and let's say, where a person doesn't get frightened trying to come into a space like this.
These machines are usually put in existing hospitals and basements and covered with lead, for the same reason. And this is very handsome compared with anything I've experienced.
That was the main objective. Just a nice, friendly little building for a very serious process. We also took the liberty of exposing all the utility pipes and everything. Just gave them some interesting color.
Mm-hmm.
And you see there the nature of the wood as it extends out into the hallway. And one of the things that the clinic liked very much were the little offices. There's like, I think, half a dozen or so of those, because they have the wood ceiling and they have a nice little wood arch over the window that looks into that courtyard space contained by the window. So all in all, it was a very friendly building and comfortable and quite handsome building. And I have been by there recently, and they have, to me, added an unfortunate addition. But I think that's just, the medical field is advancing so quickly, it's hard to keep it pace.
Yeah.
So,
Well, I recognize the Firestone building from the old photograph.
mm-hmm. That is the Firestone building. One dates from the early 1900s. And Firestone was in the, this is in Akron, in deciding whether they were going to move out of state or whether they were going to stay here. The date of this is 1983 or thereabouts. And the Firestone Corporation made a statement to the Akron papers that yes, they will stay in Akron, but they're going to modernize and renovate some of their buildings. So we were hired to do some of the renovation. They were going to use it for office spaces, and the windows were replaced with more office-related kind of functions, so more weather appropriate and things of that nature. And then they were going to, they had a little tiny space off of that tower where an existing office, where the main entrance office space would be, which was not appropriate for what they were really looking at. For a corporate, worldwide corporate office, they needed something more stately, where they could receive people in a more appropriate way, as well as create space for their corporate company display areas of various materials and products, and just developing that. And so we were engaged to do that. So this is their corporate headquarters, lobby, and entrance. It wasn't easy. There's a plan. Well, you can see at the bottom the space that was where the major part of this new office entrance would be, and it's just not very pleasant. There's lots of columns. It's kind of grubby. This was just prior, the photograph was taken not too long before we started the project. And lots of columns. So I developed a plan using the existing columns where we could, but took out a couple. Now this is underneath structure for that tower, the tallest part of the building. So again, the structural engineer was a great asset in developing structural requirements to reinforce taking two out and yet not having the building be damaged, which left enough space. So essentially we took out where the center of the arch is, where the seating area is for people as they come in. There's are up above that on the upper floors, and there are drawings for that somewhere that you can see, and created enough space to get a nice comfortable seating area and opens up the space dramatically. The curve continues around, and there's a blank wall in there now, but there are spaces for lighting up above that. It's a series of wood slats that have lighting up in there.
Norm, the project next to you is an extremely complex project for the United States Military Academy at West Point in New York. And the drawings that you have produced for this are just exquisite. Would you please talk a little bit about how you designed this very difficult project within an existing situation?
Okay. It is a complex project, but that's what made it interesting. But let me tell you how it started and when this project was active in design. I had been working occasionally for the URS office on certain projects when they came in that they thought they needed help on, or that I'd be the one that would be complementary to their office, would work well within my schedule. So this project first came alive in 2004. URS office in Columbus was and URS office has multiple offices scattered around the country with various disciplines, so it's not just Columbus. And many of them, for example, were used during the course of this project as it went through its various phases. But in 2004, they invited the URS office to participate in the interviews, and they would make a selection. And after that interview, which took place, I think, in late October or something like that in 2004. A couple weeks later, they were notified that we had been selected, URS had been selected for the project, and they'd hoped to start shortly after the new year. Well, that never happened. Things never went as planned, and there had been a couple of attempts to get it going, and the project manager went to meetings, but it still didn't succeed. Finally, in 2006, they said, well, now we're ready to go. And so we began to get ready for the project. And I remember I was in Cleveland, and they told me I could start work on August 21st in 2006. That was a memorable day, and I remember it because it was my birthday. So I come to the office in Columbus, and I had been there before, so I was very familiar with the territory. I'd worked on a couple of projects with them at the Ohio State campus. But I'm the only one in the office who doesn't have a computer, and I never had the opportunity to learn how the computer. So I'd hoped maybe they'd be able to teach me. Well, they had an IT guy come, and there was this big chunk of equipment on my reference board. And I tell you, it just didn't work. He'd talk to me in his language, and I didn't understand what he was saying. It would take a half an hour for him to show me how to log on or whatever you do. It was, and then he'd get a telephone call, and he'd have to disappear. And anyway, after about a week or so, it just knew it wasn't going to work, so they're going to take that away, and I'd have to do everything the way I'd been normally doing in my architectural design practices. So that didn't bother me one bit. I just wished I'd had the learning experience, but it wasn't to my avail. The rest of the office, all were on computers. So I started gathering information, and a lot of these drawings were examples of the existing facades of the building. I just took the liberty to put it all together as if it were one horizontal thing, because I wanted to see how one side related to the other. And the existing complex is made up of 3 separate buildings. If we start on the left one, that's the Bartlett Hall was the name of that building. That was the first of this complex, and that was designed in around 1913 by Cram, Goodhue, and Ferguson. It's all granite construction with detailing in limestone, and a beautiful building. All these buildings, by the way, are on the National Register for Historic Preservation. Then coming around to, if that side were turned, this is the part you'd see that. And there's a little extension here coming up to here. This is not part of it yet. So it was this and that, and then it turned around the other sides in the equal fashion. So it's by itself. That's 1913, 1914. Then the second building, that a direct attachment to that was for their science studies in their laboratories and things like that. So essentially that had not been a major modernization to this point, to the 2006 point. It was, I suppose the equipment had been changed over time, but the basic spaces were not changed. The second building then came, it's really this much of it. There's a tower, this much to here, up to there, and then this piece back here, this part is right over there. So it's from here, here, and all of this to here. That's the second building. That was dated to around 1930s. Then the third building, which was not sciences, this was direct attachment to this building. The floors match. This building and this part of it is a library building that had been used until just recently. So it would be space that was available for expansion to the program of sciences. The new building that was located right across the street for a new library across the street. But all of this space was available for the science program. However, it did not match the floor levels, and connection to those would all have to be part of the design program. But the basic space and a major mechanical space that was a part of that building would be utilized for the main mechanical space, renovated, redesigned for then the entire complex. Because all of the mechanical systems, electrical systems, things of that nature would be changed to the new program to fit the new program of laboratories, etc. So that's the basic complex. It's a very tight space. You don't have any room to really expand outside the walls that exist. And of course, it's all registered in the National Register for Historic Preservation. The entire campus of West Point is on that listing. So that had to be, again, another major consideration. But when I started then to do the actual design, and remember, all my colleagues in the architectural team were working on the computer, and I'm the only one not working on the computer. So I started to draw elevations first. I first had to see what we had, So that's why I took all these kind of elevation looks to see how the thing worked one from another. There's all little bits of difference in design because each firm made their own modification. But in essence, the material of granite is the one element that stays true to the entire complex. So I start drawing elevations. And I don't have one here, do I? No. But that led me then into working out whatever I had to design. I had to do it by drawing. And many of these then are that. I made this drawing from a photograph and just to try and explain to me how they attached each other. Here is this building, and you can see how it's attached. Here is, see, there's there, and here's that little part that is this one. Then the second building came along. It's from this tower. That's the tower. These up to here, and then here's that one spot that goes over there. That's this one is that one. And then the third one is what had been the old library is this one, starting here and going to here, attaching directly to here. But again, remember the floor levels don't match. And it was interesting when he took that to the first meeting. They got all interested in it, the faculty, when they were coming to the meetings, and because they hadn't looked at their building quite like that before. They were, they had not been dealing with this building, so they it was a big asset to them. And then among the first things that had to be looked at were some of the mechanical elements. I'd made a series of studies of an element on the roof that might happen up above these spaces up here. And that would be, it was potentially workable from an engineering point of view, but it created some other conditions that weren't acceptable. It was essentially engineered out, not adaptable, without more cost and other products. So we had to find out where the mechanical spaces were going to be. You get things like cooling towers, big pieces of electronic equipment to be developed in the space. We could use that existing mechanical space, but that was in this building, but on the other side. And so that just had to be a part of the requirements of the program, I think, essentially because it would have been too costly and too involved to put everything on the roof. We could put certain things on the roof, and I'll show you some of that. The area up here, this is the existing roof of the library. That's the existing, this roof. There are cooling towers and things in there. There's new cooling towers that are here. That's a new element on the roof. And then there's an element here that had some other equipment in it. And here's the existing tower. So I tried to show how this can be adapted to work together with these elements just by well, in an elevation you see it here. This is the new cooling tower. That's the existing tower. And well, yeah. That's the existing one. And from an elevation point of view, that works here. Here's the existing cooling tower. Here's the new one. And there's the existing tower, not mechanical, that's this tower. And when we showed that, it works mechanically, and in my view, it worked by just picking up enough of the details, these top elements of limestone trim, along with the family of all that occurs. It was the first simple application of how that could fit. And when it was shown to the historical preservation people, they thought that was great. The one person in New York said he'd always thought that little group there didn't quite work. Now that third element comes in, ties it all together. And later on, I should say that the historic preservation people they had a group of them direct on the campus of West Point, so they were involved in each and every project. And they liked what I was doing. In fact, the fellow at West Point said he wished Perttula could do all of the Cram Goodhue and Ferguson editions. I should say Bertram Goodhue was one of my architectural heroes, so that made me feel very good. So mechanical equipment was essential for all of that. So I had these photos of the existing condition, which wasn't a great spot there, but it now becomes in a much more forefront because of using this existing doorway as one of the major entrances to the complex. Had to be made a little better looking. So I developed these studies to show how that would happen just by arranging the elements slightly different and put a grating over the big hole. And then there's a wall that's created along there, stepped it on with following the same kind of details that exist around the campus of a trimmed limestone top, and ties that right in there and looks more natural. Certainly more handsome. And I'd give this to the team, who could then go from here to the computer and plug it into the drawings, the computer drawings, which had to be, when we were at that stage, all the drawings had to be on the computer, which is probably more typical now, I guess.
Yeah.
In 2006. I'm not sure, but so I just followed that example. I'm used to making these kind of sketches anyway, for, as you've seen here and there, some of the things. So it was not a burden for me. In fact, it worked to my advantage. Every once in a while, there'd be some default with the computer system. The office would be waylaid. Guess who's the only one working? And didn't bother me a bit. And the crew got used to it, so I kept making these developments throughout the project, and that's really what these drawings exhibit for various places. Much of it was internal. I'll go through a set of the drawings over here. Most of these are external things or elements on the roof, things like that, and then I'll come back to some of the other that are interior ones, but because the drawings are all in this position, they all have a certain relationship. This is the 1930s building, Paul Philippe Cray building, and there are a number of things that the architecture or the engineering required. We had to rely on excavation in a couple of major places, this being one. It was an ideal location. Let me see where I can illustrate that. I guess probably on the drawings over there, but There is a doorway over here, and the ground is sloping down here, and this portion up around this point is unexcavated. But there's a section that is available at one end of that, but it's just got small rooms that non-major functions in there. But it was a possibility if we excavated in that area and changed some areas that were on an existing area, but not with a high ceiling area, but lowered the floor levels, we could gain some valuable space. And after checking it out with the engineers, it was determined that, yeah, they could get their engineering equipment in there if we excavated to a certain level. So this area along in here, here's the doorway existing, and that's where some of the kind of available but not highly efficient for mechanical use or for even some of the laboratory space. If we could lower that floor, then we could get that space and use it for laboratories, and then excavating over here, not all the way to this doorway, but far enough that we could, up to here, we could utilize that for equipment space. And so that was done, and what was done architecturally, underneath here is the excavated area and on that slope. So these are new window areas, and we're simply going to use the same pattern as exists up here, except they'd be with vent spaces rather than a window. So the architectural character remained, and this becomes very much similar on a smaller scale from the one I described for you over here. So there's one, this was an existing large area where existing mechanical space. Many of the elements in there were just removed, so they had a much bigger volume of space, and that was very successful for certain mechanical equipment. And this was then the second area that was made available by excavating out. On the roof area, this is another area where there's large mechanical equipment. That's this space up here. Here's the tower, which is right there. These are various pieces of large equipment, mechanical equipment. All these walls, this was an early choice I made that was approved, and a very lucky one. You walk around the campus and you see a lot of things sticking up above the roof. Many of them are metal walls, you know, the usual kind of thing. But all the walls that we have of equipment up there, you have a granite exterior. So what you see here is a new granite wall. And again, I've just followed the simple detail of combining these horizontal strips to coordinate with existing strips. So you get a nice continuity of feeling and of material. The one thing I don't know is we did not have the advantage of observation during the construction. It's not unusual for the government to change those kind of contracts in the midst of the job. And the folks we had inside the URS office doing the mechanical equipment up to this stage, when construction began, they changed the mechanical engineers. And so I hope there wasn't any change to these kinds of things. But the other particular element that I haven't personally seen is there's granite on these three buildings, but it's not the same granite. It varies slightly. So what we were trying to do is see if we could match to what's existing there by putting up a sample wall. We did that on the first phase, and that worked out good. So I haven't seen the final phase in its existence. Okay, so that's mechanical equipment stuff. Here's another example. Do you remember the photographs on the wall back there where there's this tight staircase going up between two buildings? Well, there's one over there. This is that space. And here's another area where we wanted to get, there's an existing floor level at this point, and not a high ceiling room. And if we could lower that, we could make that space much more usable. So I simply looked at it and said, well, I guess we could change it. We just have to make an adjustment to the stairway, and this is an existing opening and this is an existing opening. This was where the door was. See the photograph up here? That's this area. And here's the window over here. So I just showed the doorway comes here, and this is the due elevation back into here. That's been excavated. And we have to create the stairway to get a landing here, and then use the same type of treatment here. That's existing as for the doorway, and we just did something similar with a window here. So there's a window here and a window here and the door there. So that's another small but important area to maintain the same character. And again, just turn these drawings over to the rest of the team and they'd work out the details on the computer. This is the project over here that came in late in the program. It was not funded, but they asked us to make a study. There's a store, see this little court in here in between the three buildings? That was full of mechanical equipment when we got to the site. That's what they used it for. And so they asked us, well, couldn't we do something there? Couldn't we make something out of that space? So I said, well, they authorized us to make a study. So this is what came out of that study. It took the needed space. This is existing to here. We added that so that we got this floor level at the same level as the main entrance. This is a little project that the West Point people, the two colonels, asked if we could do a study. They talked about a large covered space in the court, essentially cover the court. They could use for different kinds of functions, and they had a name for that that I forget, but a multi-use flat floor, large space for get a good big group together. And so with that program, I took a little look at it. This was not in the budget, so it's just a study for whatever, future use potential or whatever. And in the course of it, there were spaces that they could utilize that were not programmed on the two lower levels. And then here's the large open space. I should mention that the entire construction as it exists from the beginning had to be designed for earthquake conditions. So URS has an office in San Francisco, and their engineer, who's very familiar with earthquake, was the fellow who designed and developed the course of how to design these and preserve the architecture, the exterior architecture. And the solution came out that it would essentially be an interior wall surface wherever there's not a window or a door that would be about 14 inches thick on the average, and with an occasional then shear wall inside. That would not mess up the plan in a major way. So that was what was engineered. So I used a portion of that, so you see it here, you know, so that we get these elevations of these buildings weren't all the same up at the
Correct.
top. But taking that concrete and raise it up to a consistent level, then you could develop a system of some sort. This is just illustrating one type of solution. There could be others. That's shown in the roof sketch over here. And yeah, and over here. That shows you the complex and its neighborhoods.
So this roof was not in existence?
No,
Okay.
that's open to the
Yeah.
open to the court level, which is down
Yeah.
here. And they loved it. Of course, they didn't have the money, but maybe at some point they will
Right.
be able to do it.
Future.
And this is just a detail. If you follow this all the way through, you'd come to the center window, center doorway of the Cram Goodhue and Ferguson. See on that end elevation? The center of the building is the main entrance. That floor continues on to an existing floor here. This building wasn't here in the original construction. It came out to an open landscape space. So all of this detail is there and just had not been used. And so this would be then coming into that new space, this area, and that'd be the new floor area here. I just wanted to show the detail of the wall and meeting the floor and what this existing entranceway looks like. The floors in this building are all terracotta floors like this, but square, I think 9-inch, and intermittently lined with like a, they had a name for it. It wasn't a slate, but it looked sort of like slate, where they'd get linear pieces of it. And on the first floor existing, it had been covered up. So we uncovered it and brought it back to its original look. Some of that shows up on the picture over here. So that just came in. I think everybody might like to see it, but they're not in control necessarily of all the funding. I don't know how that works.
Well, unfortunately, the military keeps moving people around too, so the people that were excited about it and wanted to push it are probably somewhere else.
That's true. One of them is, at least, yeah. One. I mean, the drawings helped them. They were a big asset in understanding what I was working on. Much easier than just from plans or things. And the science colonel, after we'd finished a meeting, went over the project. I used to bring the drawings like this on my yellow tracing paper, and so they knew they were just, sketch ideas, and we'd make comments and know where things were right, or where maybe something new should be added to this. So you'd work together over that, both understanding what you're looking at and what you're relating to. And then the chemistry man would go up and get his staff and bring him down to make his own presentation to his staff. That worked from that point of view very well.
Norm, you have an exquisite ability to freehand draw. And ever since I have known you, I have admired this ability. And it appears to me that you use it in a number of different ways. One is for field research for projects, going out and sketching existing situations and like opportunities and so forth. And the
Yes.
other way is for presentation to clients. And behind us, you have some beautiful drawings of the academy, the interiors of the academy, and they're very soft compared with computer drawings that we generally do now. And one of my concerns is the ability for architects to be able to sketch for clients is being lost almost. And I wondered if you could talk a bit about where you developed this great talent you have and how you use it.
Well, I've always done a lot of drawing in my career, and I used early on drawings as a part of the design process from the very beginnings throughout all the minute details that may happen. It's just the language that I'd use to convey what I'm thinking about and put it on paper as a drawing, and then use that to develop into a final design solution. And West Point now, the interiors are a tradition. There's many traditions at West Point, and some of those are things that I'd observed while we were working on this project and tried to incorporate those. There's a certain quality of design that has been done in these beautiful buildings. And as you know, this whole campus on the historic register, that's an important aspect that we have to keep and control and continue to develop as required when you're working on these older buildings, but have to bring in some of that tradition into the character of the interior. So that's what these sketches and designs kind of look like. They also served a very necessary purpose as we were working on the project. I am from the older generation. I do not use the computer. I tried to use the computer, but it became just impossible. The computer people who were trying to teach me spoke computer language, and I don't understand that. So it was just impossible to continue, and I had to abandon trying to learn the computer, and I was disappointed at that. So I determined that I could develop my sketches in much the same way I had done as I would have been studying the design solution, and then pass those sketches on to the design team who were running the computers. Everybody in the office was on computers except me. And so that's what these represent among some of the more important spaces, the interior spaces. And for example, there was one area which was called the gun door. There's two cannons outside of an entrance into one of the buildings. Apparently it was the first shot fired in the Civil War on one side, and the last shot fired in the Civil War. But it had been locked, and they didn't use that door because it had been the former library, and they built a new library across the street, so this space was, during its library use, was just locked, but still the gun door is there. So in our new planning, it became a very major new entrance, and so we had the opportunity to design the interior of that, which was just an ordinary hallway before, into a more appropriate space with new design. Allowed me the opportunity to design a new arch inside, which is often used in other locations on the campus, and things of that sort. There's sketches of that you can see here. Then there was a circumstance when the new library, which was being built while we were doing our planning, when the bids came in for the new library, it ran over budget a bit, and so they had to make some cuts. And one of the cuts was the main archival space for the entire campus of West Point. And it was determined that, well, they could put it in our project. It's a fairly monumental space with the storage and all, but among all the artifacts and things like that that they have, made for a very interesting architectural study.
Mm-hmm.
And after a period of time of trying to find the right locations, it was never the new program for the existing buildings were to develop the entire new science facilities, laboratories, and things that were part of that program. And so the two buildings that were built, the first in 1913 and the second building in about the 1930s, were the existing science, and then the third building was the library, the old library. But among the archival things that had to be required was a reading room, space for many special private collections that came in. For example, MacArthur's desk is a part of an archive, and that's located in a very prominent spot. And General Marshall's office was fully part of the archival, and we had need for a conference room, so we used the rug that had been in General Marshall's office as part of the rug, things of that nature. Those were among the interesting design studies we had to develop that were not your typical thing. Then we developed administrative space for both the science department and for the physics department, which meant for new layouts for the administrative staff and a new office for the department head and the assistant department head. And those sketches were also had a more special character than the typical offices. So those are the type of sketches that were developed in this phase of the project, and I used them both for design study for development of the space, and then just turned that over to the architectural design staff to produce on the computer. Mm-hmm. It worked very well as well during meetings with the client. They could see what we were proposing and make comments and additions as required, and so we'd work very comfortably together to come up with a solution that's jointly acceptable.
Good. You have a number of sketches on your credenza from different projects and so forth. One of the things that I always was fascinated by when I would speak to you is your travels, and I have not seen all your sketches from your travels, but I assume there's many.
Well, when we traveled, my wife Helen and I took photographs. Okay. More than, so I've got a whole bunch of photographs that cover much of the time in Europe. The 11th and 12th century were our favorites, but it's all in photograph.
Okay.
Sorry. But I have other sketches here that I like to draw, and there's a variety of sketches, drawings here that were, there's a few of the major churches in the Cleveland area. They weren't a project, an architectural project of mine, but a group of the architects, mostly among the fellows in the architecture departments, or our fellows in the architecture program. A program was suggested, why don't we get the fellows to make sketches of all the monumental, personal, important buildings throughout Cleveland, and we could use that information for publicity, develop posters, develop calendars and calling cards and little note cards and things of that nature. And everybody thought that was a pretty good idea. So they said, Norm, you do a lot of drawing, you can be the chairman for this program. So I went and gathered the name or identity of various important buildings throughout Cleveland. And since I was the chairman, I picked 3 that I wanted to do, which were the Cleveland Museum of Art, the Epworth Euclid Methodist Church, the oil can church as we know it. That, by the way, was designed by one of my hero architects, Bertram Goodhue. And then the Garfield Monument Cemetery. Well, I did those 3, and nobody else did them. So the program kind of evaporated, but so we have have those 3 drawings as part of what it. I had intended those to be sketches, but that ended up as the final product. Then I have some sketches of, well, a little more finite, with the Cleveland Arts Prize. I had been on the committee together with Dick Fleischman and Pete Van Dyke as group, and we decided among the things that might be interesting to do was to produce a medal, and that was done jointly. And then I had the idea of a flag that would be held by one of the groups that's part of the Cleveland Arts Prize. There were 3 categories. There was architecture, music, arts, dance, and I can't remember now what, but so I made a drawing of each of those as if it were a large flag that would be on a post, and a member of that category would come marching in during the beginning of the program, and then they would all stand up on the stage and become the backdrop for what takes place on the stage. So those drawings are part of my sketching, which is a different type of thing that I've done ever. And the third was, I live in a planned unit development in a community called Walden. And my time here, I'd had the opportunity among some of the occupants here to put an addition or make a small remodel of some part of the unit. And so I enjoyed doing that and helping the community to do that. There's a very distinctive character, architectural character here in Walden. It's the same materials, the same roof materials, it's the same roof shapes and slopes. And I had no intention of changing that, but how to work something in to make it look as if it had always been there. So I would work with generally a photograph of the existing building, existing condo, which picks up not only the building itself, but whatever shapes and details are in that building, and then the environment. It's a very heavily wooded area, and that's very much a part of the environment. So I would try from a photograph then to capture that existing building and then make a new drawing that shows the existing building with a new addition added, so it's very clear to the owner and the client of what the final result is. And it's been very successful. I have a successful client here as our guest in a photograph of her condo unit. And she has told me many times that it's the most comfortable room they have in their condominium. It's a nice, small, but very comfortable sunroom with an attached deck. And it had initially started as just the deck when the condo was first built, but that was beginning to deteriorate. In some places it was could be dangerous. And so from that area then we created this room and a little bit of the deck, and it turned out to become a very successful place for that family. So those sketches are here for a number of other such units. But I'd always start with a photograph to capture what's there, and then work from that into a plan that works into their operation, and then make a drawing of the final thing. And those sketches, I have a number of them here that you can see.
So you do use photographs to document existing situations and so forth, and then come back to the studio and draw from there?
I always have, of various types. Just to get an idea of the total site, I would go out there with a Polaroid camera when those were available, and just stand in one spot and then sort of whirl around so I'd get a big continuous length of what the area is like. And in other instances, I would be, if it's a building, I'd like to get more specific on, like West Point was very important. It was very important to see what the existing building was, exterior was like, both to get what the positive details are, but also the negative. On West Point, for example, because of the historic nature of the campus, everything's on the National Register at West Point. You don't want to do any damage to anything there by adding or changing something, but you might be able to make some improvements. And we tried to do that as much as we could on West Point. There were here and there a number of holes that had been cut through the wall for various mechanical reasons or whatever. And there was a couple instances where something had been raised up above the normal roof line that was just inappropriate, but it was used for some mechanical piece of equipment. And we were able to remove that because we developed a whole new mechanical system, electrical system, so some of those things were able to be corrected.